Okay, welcome back. We are going to move on to splitting the data sets and start preparing the data so that we can actually start training our machine learning model. In this tutorial, we're going to split the data and keep 10,000 of it for our so-called test set. How we are splitting this is that the first 6,000 we park this under training. The remaining 6,000 we parked it under test. Okay, so the same with the actual target as well. Okay, so now just a simple tip here. I don't want to type it out. I just want to read it out to you. Typically, we shuffle the training set. This ensures the training set is randomized and your data distribution is actually consistent. However, just please do keep in mind that when you come to time series data, the actual sequence of the data is important. Shuffling is a really bad idea. But since we're actually doing this for the actual digits itself, we will shuffle the data set since it is actually a good practice, and I will import NumPy as well. Okay, and we are going to shuffle the actual data itself. So we're going to create an index is equal to NumPy's random, and we're going to have the using the built-in permutation for the 60,000 data sets that we had earlier, and then using this index we're gonna just reshuffle our training sets for both X train and also Y train. So for the X train we're gonna use the shuffle index, and for Y train as well we're gonna use the same shuffle index. Okay, having done that, we're gonna move on to training our data sets. Now, I want to build this up slowly, same way that the scikit-learn has done it, rather than trying to train our classification on 10 different digits, meaning 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I am going to just train one. Okay, so meaning what I'm trying to do now is actually just to simplify our problem into a binary classification. Okay, rather than a multi-class classification, I'm changing it to becomes just binaries, one class. So I'm gonna just make this an exercise of either the digit is 0 or not. Okay, 0 or non-zero, is making it a two-class problem. So to make that work, we need to first convert our target to 0 or non-zero. So remember, our target is Y train, and we are creating a new target here called Y train underscore 0, and we're gonna make our Y train everything that is equal to 0, we store that into the Y train underscore 0. Okay, sorry, let me rephrase that. What this is actually doing is that if it's equal to 0, then yes. If it's not equal to 0, then it's false. So let me just show you that. And we're gonna do likewise with the test data. Let's go to Y test 0. Okay, wait, should be Y test. Okay, so there's some true, some false in there. Okay, so at this point, at this juncture, basically we can actually pick any classifier and train it. So this is really the iterative part of choosing and testing all the classifiers and then tune the hyperparameters. We will start by using a linear model called SGD classifier. The SGD classifier automatically defaults to support vector machine learning algorithm. The estimator here implements a regularized linear model with the stochastic gradient descent learning. The gradient is estimated at each sample at a time, and the model is updated along the way, and eventually comes to the minimized loss. And the model can be a linear support vector machine, or it can also be logistic regression. Depending on how you set it, if you change the log loss, which gives you a logistic regression, when you set to hinge, it will give a linear support vector machine. Now, to understand more, let's go to the user guide. I've opened it up here. This part really talks about the stochastic gradient descent, how it actually tried to locate the minima or the loss, find the lowest loss in order to estimate our coefficient. Now, the idea here is that it is basically using either support vector machine or logistic regression. And what it's trying to do here is that it's trying to segregate the two classes. Essentially, this is also the exercise that we're trying to do here. It's trying to fit a line, okay, and trying to actually have the maximum in terms of the so-called distance between these two classes. So it's trying to actually identify the slope and also the line as well that can actually find the greatest distance between the two so-called clusters of data, or two classes of data here. Now, earlier we saw that you can actually set a few things, hinge, log, and a few others. So let's come down here to understand what are the implications of these parameters. When you set it to loss is equal to hinge, which is actually the default here, is what we call soft margin. Basically, it defaults to the linear support vector machine. If you change it to modify Hubbard, it changes to smooth hinge loss. If it's logged, then it's logistic regression. For now, that's sufficient for our use. Let's go back to the classifier itself, and let's train it and understand how the process works. Okay, so this is the training portion. So from scikit-learn and from the linear model, we're gonna import the SGD classifier. Okay, and the step is that we're gonna instantiate it, and we're gonna set the random state is equal to 0 and fit that to the X train and also the Y train 0 data. Okay, so provided some value for us. So now we're gonna move on to the actual prediction itself. So once we trained, we can use the actual classifier that we trained, which is CRF, and conduct some prediction. So remember, the 1000 is actually a 0. Okay, this is we actually did that here. So you know, remember x1000, we plot the image is a 0, and the actual target value is indeed 0. So if our classifier is any good, this should predict it as 0. Of course, one data point doesn't tell a lot. Notice that it is false. So what this is actually saying is that it is not able to actually get that right, unfortunately. That's the end of the video on running the training of our machine learning algorithm, as well as running the prediction itself. So this is just really one part of the whole exercise. In this video, what we've covered is splitting the data to training as well as the test set. We also show how you can shuffle the data sets here. Now, the alternative to using NumPy permutation is to use scikit-learn library, whereby it has what you call a shuffle split. You can make use of that as well to actually split up your training and also test data set. In this case, what we've also done is to train our binary classifier, meaning is true or false, and we also use the SGD classifier. In this case, we utilize the hinge. Okay, it should actually say here hinge, which is the loss here is hinge, so that means it's a linear support vector machine. And finally, we ran the prediction. Unfortunately, it turns out that the prediction wasn't accurate, but that's quite all right. What we're gonna do in the next video is that we're gonna perform something that's a little bit more robust to measure the performance of our classifier, and we're gonna make use of a method called cross validation. So I look forward to seeing you in the next video.